after measuring some things, thinking about it, I've decided to stick with this plan. So I'm going to put the same size hole in both ends at this point. This will become a 1/2 inch hole eventually, but I'm going smaller than that for this phase. This one I'm taking out to size, so I'm going to ream them both to 0.312, which is what the drawing calls out. There we are, clear evidence that we're through and into the slave plate. Back again, and now I have the connecting rod set up vertically on the angle plate. The 312 pin does actually go in. It's a very close fit, so we're basically what we call line on line in there. A 311 pin has some measurable wiggle, so in estimate terms, I suppose the reamed hole is probably just shy of 312. This is a 312 minus pin, which means it's between 312 and 3118 inches in diameter. Anyway, this being a close fit means that this is nice and solid, and so I can use this to set up the height of the slitting saw. Now, where's my pointer? Here it is. So to get this vertical and maintain orientation, I've touched off on these two surfaces, which I know are at the same plane, and then I also used my machine feature to double check it. So I'm going to prove that. So I'm going to bring this down. The test indicator shows 0. And you can see Z is minus 0.2 of a thou. Lift up. Go across. Back down. Test indicator to 0. Z is 0. So there's 0.2 of a thou difference between those two, but the resolution of the DRO is 0.2, so that's plenty good on a part like this, honestly. So back we go. We'll try this. So what I'm going to do is lower the slitting saw down. Now this is only a 1/64 thick blade. It's the thinnest one I've got because I want to take out the smallest amount of material I can when I separate this. So that's going to be too easy to set it down on the pin and distort it. So I'm going to use a 5 thou feeler gauge to feel when it's on the pin. Slightest of drags there, so I'm going to zero the DRO now. So now I know that the bottom of the saw is half of 312 plus 5 thou from the center line of the hole, and then I also have to take off half the thickness of the blade in order to get it on the center of the hole. So I'm going to center it first, then I'm going to come up off center enough to leave machining stock so that I don't actually cut through the center of the hole. I want to be higher than that and then come back down. So I'm going to come off the part for the moment. So to get the blade center on center of the hole, my calculation says I have to come down 0.1703. Can't do 1703, I have to do 0.1702 or 4. So that's half of 312 plus 5 plus half of 18.5 to the blade thickness. So that is 1702. Now I've re-zeroed the DRO, and if we just bring the table back over, that certainly visually looks like it's on center line. Right, so the blade thickness is approximately 18.5 thou. So I need to come up half of that, so 9.25 thou, in order to actually have the bottom of the blade skim the top of the center line, or skim the center line of that hole. But I don't want to do that, I want to leave a bit, so I've got to come up more than that. So 9.25 plus some. So I'm going to come up 30, which will leave me roughly 21 or 20 thou to clean up. I'm going to lock that there and move this over to get the pin out. But you can just see that there's a very light scribe mark, and it's very definitely off center, which is exactly what I want. By just a small amount. So Haven't done much slitting saw work, so I'm sort of feeling my way through this. So 312 pin is back in place, and what I'm doing is I've found the top of the pin by moving the table backwards and forwards and zeroed the test indicator, and what I'm doing is just checking that the axis of the pin in the X direction, that's the pointer direction, making sure that the pin is not tipped up or skewed. Make sure the part hasn't moved, because I want this face, when I machine it back, I want that as parallel to the center axis of the pin as possible. So to demonstrate that, this should be on the highest point. If I go backwards and forwards, there we are, see how it crowns at the 0 point. And now if I move it in the X, that needle hasn't moved at all. Now I'll check the crown again. Look at that, absolutely on. So within my ability to measure it, the axis of the hole is perfect and trammed to the machine. So now I know that when I clean this surface up, it will be as square as it can possibly be to the pin. So that makes me very happy. So I'm now going to set up an end mill. When I set up tools, I usually spend a huge amount of time faffing around, and so I'm going to turn the camera off while I do that. Right, got a nice sharp carbide cutter mounted, and I'm going to use the same trick. Not really a trick, is it? Just a good technique. I'm going to use a feeler gauge because I don't want to chip the end of my beautiful expensive carbide cutter, so I'm going to use a feeler gauge to establish the height of the cutter over the center of the part. There we are, there's a drag there, and I know that the tip of that cutter is over the vertical center of the pin, because if you move the table backwards and forwards, when you bring the cutter down, it will deflect the feeler gauge down or up, and so you can move the table back and forth. I did this off camera until the feeler gauge stays flat, then you know you're very close to the center of the tool, so this height will be accurate. And there's a very slight drag there. The slightest adjustment makes it dig in. It's not even enough to change the reading on the DRO to get it to really bite that feeler gauge. So I'm going to zero the quill there. Now I know I'm 5/1000ths of an inch above the pin, and so I know that if I go half the pin diameter plus 5, I will be right on the center of that hole. Pin diameter is 312. So that's 0.156 plus 5 thou is 161. So I know that if I now come down to 0 minus 161, that will be right on the center line of that hole. So I'm actually going to re-zero the DRO at that point, and I'll work my way down to it. Alright. I've cleverly removed the angle plate before I'm actually done with it, so that will have to go back on, and in the meantime I've got my milling vise set up and I'm going to machine the top cap. Now what I've done is measured the thickness of each side and they are identical. So to set this up, all I'm doing is touching off here and here, and I've adjusted the part until it's level, so I'll just show you that quickly. There we are, touch down, move the needle to 0. We will attempt to look at the DRO. Right, focus this again. Come on. Needle back to 0. And you can see we're 4/10 off there, which I'm just going to call plenty acceptable for this. So that's how I got that set up. Ah, there we are. I think we got focus again. So now, to remove the test indicator, and begin machining, and all I'm going to do is just go for cleanup on this surface. There isn't a set dimension here. I want to lose as little material as I can. I just want this flat. So there we actually, I don't know if you can see that, but there's a little surface there. So just to talk you through the next part of the sequence, we have the split connecting rod here, and we have the cap, and I didn't show you this yet, but here's the 312 pin, and that's a perfect fit in there. See how I can just push that down. So the plan will be to set this up like so, again on our slave plate, and what I can do is I can use this pin clamped into the bore here, and I can use that to accurately find the center of that hole. And then having done that, I'll get the pin out of the way, attach the top cap, and then I can drill and ream the big end hole. And that will be it for this stage. Then we'll move on to adding the notch up this end. So that's the plan. I'm going to get the slave plate clamped down, figure out my clamping for this, and then I'll come back. Right here I've got the connecting rod set up now on my sacrificial plate. Plate is clamped down, and then I'm using the miniature aluminium toe clamps to hold the part in place. And I'm using the separated cap just to hold the 312 pin in place so that I can center this up. Now what I'm going to use to find center is this coaxial indicator. These are sometimes known as a Blake indicator, and I'm very lucky. This was a Christmas present from my wife, and I love this tool. Now, truth is, if you know how to use a test indicator to establish a bore, that performs the same function as this, and but I just find this a very fun tool to use. So just for the fun of it, I haven't seen many people demonstrate these, so thought I'd give it a go and show you what they're about. And the idea is you have a very long travel. You have a probe tip here that goes around your cylinder. The barrel of the part, as you can see, can move a large amount up and down, and you use the X and Y handles to adjust the position of the table until this needle stabilizes. So you just run this at very slow speed and adjust the handles until you get there. I have a aluminum block in my milling vise just as a stop for this handle. I wouldn't normally need to do that. You can just do it hang on to this with one hand and adjust the table with the other. But with the camera in place, that's a little tricky, so this takes care of that for me. Alright, so on we go. There you are. So you can see the needle oscillating backwards and forwards, and now we just adjust the XY table and reduce the amplitude, and usually you find it's a combination, and pretty soon you get it to a point where it's barely moving, and there you can set your X and Y 0. And that's it, that's 0 established. I'm going to see if I can tweak it a bit more. good as I can get it. Done and dusted. With that done, what I'll do is remove the pin, remove this gauge, and get set up to finish this hole out. Now what I'm going to do is, this hole is not going to be circular. Half of it's going to be circular, then it's, when the cap is bolted back, it's not going to be a properly circular hole. So I'm not going to drill it immediately because I think that might play havoc with a drill. What I'll do is I will put a 3/8 milling cutter down first, clean that out so that it's circular, then I will drill to 15-30 seconds according to the drawing, and then ream to a 1/2 inch. End mill's set up, part is clamped, I have the cap securely in place, I'm at 0 X and Y, and I have a pin supporting the cap. I can't leave that without support underneath it, even if it is tightly clamped. Pin is the same diameter as thickness of the two slip gauges that I've got in there. So first step is just to clean out the bore to a circle using the end mill, and then we will drill closer to finish size and then ream. Half-inch gauge pin. Beautiful. No play. Straight in. So we'll call that a success, and I'll clean up, get the angle plate back on the machine for the final part of this adventure. Well, I'm running out of battery power, so I don't know if I'll get everything filmed here, but we'll see how we go. So here's the next setup. Angle plate back on, which was trammed to the x-axis of the mill. The connecting rod is clamped on a piece of aluminum stock at the bottom, and I have an adjustable parallel in it to give it some support at the top. The drawing calls out for a 0.380 inch wide slot in the center of the top, 0.9 inches deep. So what I'm going to do is touch off on the lowest side here, establish the top 0 point. I've already established 0 center line between these two faces just using an edge finder. Didn't film that because there's like a million videos about using edge finders, so nothing new there. So I'm going to touch off on this. Table is locked in the Y direction already, and I'm going to plunge mill the slot most of the way down to the 0.9 inches, or I might go 0.85, something like that, 0.87. This is a 5/16 wide cutter, so I will take out the bulk of the material, and then the final 34 thousandths of an inch on either side I will take out in cleanup cuts, and that should get the 380 wide slot quite accurately. Its tolerance is 0.380 plus or minus 5 thou on this, so that's what we've got. I'm going to keep filming until the battery runs out. So let's see how we get on. At the moment I'm just cleaning up on the high side, which is going to get fettled back by hand anyway, so this is not quite my 0. Right, there's the 0 point. I'm just touching the top of the low side, so I'm going to call that 0. Here are a couple of still shots that I took, which just show the final setup of the connecting rod. I added a couple of aluminum blocks just to hold it securely. Here is the finished connecting rod, and I've given it some hand fettling to get rid of the mold lines and blend it in a little bit, and then masked up the bearing ends, big and little ends, and put it through the sandblaster just to sort of even it out and give it that more or less rough cast look. So that's it. I did blend out some of the kind of off-center feature of the little end, and that's much improved, I think. Overall, everything seems to have come out quite well, so very pleased with that, and going to call it a day. I do still have the supplied screws in here for holding the cap in place while I was blending it, but I will be making studs and nuts for that just to improve the look a little bit. But there it is. Thanks for sticking with me. The both parts actually of these two videos actually went quite long. Learned a lot in making them, and for those of you that stuck around and watched the whole thing, I do appreciate it, and looking forward to moving on to the next part. So that's it, signing off for this part. Stay safe and well, and remember, always be the sharpest tool in the shed. Bye for now.